Air University and the University of Michigan. My group was consisted of a handful of officers, and we were given the topic of contested logistics in Indo-PACOM. For the last 2 months, we've been researching and coordinating with other leaders in DoD and industry to see if we can figure out maybe a niche somewhere that we can move the needle on this very important topic to A, try and help our logistics situation as it is now, and B, prepare ourselves for a high-end fight over in that theater. I'm happy and honored to be here, and thank you for this opportunity to share my work and get some world-class feedback. Better yet, where do we go from here is definitely something that I'm looking forward to, and I would love to pass it over to our next panelist. As soon as I can pull this up, it's Doug.
Hey, Connor, I think we're all looking forward to your research and providing and facilitating a discussion, not just from your work and the colleagues that you work with, but those that have tuned in as well. It's exciting that we've got the Air University Research Showcase, which is a chance for all of us to come together. What I also think is fascinating, it's like showing the truly joint and the interagency perspective of this panel. You've got a couple Marines who are going to chime in with their perspectives. So by way of introduction, I'm a field artillery officer, United States Marine Corps. I teach strategy at the National Defense University. I've got a lot of experience in indirect fires. I'm a JTAC, call for fire, a little bit with logistics. And so I come from a perspective of, a lot of time as a military advisor too. So a lot of time out there, wondering if logistics is going to be pushed or pulled, sometimes playing logistics, and, also an appreciation for the airfield and SOF operators. So with that, I look forward to chiming in and facilitating, participating in this conversation. I'm going to turn it over to John.
Thank you, Doug. My name is John Collins. I'm a retired Marine Intel officer who has been around the UAVs on and off for about 30 years. And what I find most interesting about this conversation is that it's at least 30 years old or close to it. In 1992-ish, I did a MAGTF exercise where it was a staff exercise, and it was a planning mission to take a MEU to the interior of Chad. And at the end of that exercise, very senior leaders said, I don't think a MEU can do this mission. And it was because of logistics, because of the distance and movement, trying to take assets like CH-46s and 53s and set up FARPs. It really was an eye-opening for a young officer to truly understand. Now, my older brother, who's a retired Major General, is a logistics officer. And so that was a conversation that clearly has about logistics support, to Doug's point. And I'm sure we'll get into it more. So I look forward to this panel and the topic at hand. And thank you for all taking the time to talk through with us.
All right, without further ado, I'm going to share my show and kind of hit the main points here. And then we'll open it up for further insight from both of you and questions from the field. So without further ado, here we go. All right, first things first is we got a great quote from Mike Tyson. Everybody has a plan until they get punched in the mouth. So as we were talking to a lot of the leaders about this topic, and we were given specifically contested logistics in Indo-PACOM, and that's kind of a key point because we all have these great plans of how we're going to punch the other guy, right? We're going to punch him. Got cool missiles, cool aircraft, F-35s, wow, right? F-22 is personally my favorite. We talk about that a lot, but what happens when we get punched, right? We have all these exercises. It's focused mostly on how do we get in there? How do we get out? How do we work together with other nations? That's all good, but as a participant in some of those exercises, a lot of times logistics is overlooked. Logistics is put on a side piece. A jet breaks, an equipment breaks, and then we say to ourselves, well, we're doing this exercise here, that'll be fine. That'll be fine. Just, put the magic, the game genie. Put the game genie on it, and suddenly it's fixed. We have this piece of equipment here, but we don't really put too much thought into how it got there. And talking to Transcom leaders in particular, they had a really great way of talking about this as it relates to INDOPACOM and logistics. Right, so here's the Pacific Ocean, right? We can put this as simple as it is. We are trying to go here, right? I'm circling a particular island, and it is deliberate. It is right in their backyard, right? And if we go back to World War II, the Japanese, when they attacked us, they said, we have just awoke a sleeping giant, right? Something along those lines. Why is that? Why did he say that? The reason is we had the industry to crush everyone else. Industry could produce tanks, planes, ships. It didn't matter. How did we get across the Atlantic? We built so many transport ships that the Germans couldn't shoot them down fast enough. And then we built some more. That is how, well, we got rid of them too, but that was a key part of it. So as Transcom leaders talk about this, when they think about logistics, they think about how can we connect our nation's economic might to that of our military? How can we connect those two things? And as we're looking at this map, we have a lot of distance to cover between our industry and where we're trying to go. Yes, we have friends. Yes, we do. Sure, absolutely. But we need to get our factories moving and things across this large distance. That is not a given. Not a given. So the tyranny of distance, when we talk about this theater, is a real thing. That and the boot is on the other foot. Our adversaries in this region have the industry might this time. They have the advantage there, not us. And we're in their backyard. They don't have the tyranny of distance like we do. So we have serious problems on our hand when it comes to this topic. All right, so to talk about the problem a little bit more, we've talked to Australia a little bit. That's Griffith University. We've talked to Kratos, which is a defense security solutions company. We'll be talking about them a whole bunch. We've worked with Air University. We've worked with RAND studies. There are 2 RAND studies that are featured heavily throughout this that has some great data. And I talked about Transcom before. So contested environment. We are dealing with long distances. We are dealing with things that we need to get delivered quickly. And we also have to contend with our traditional assets could be shot down, right? We could lose. We could lose a C-17. We could lose several C-17s. C-5s, same thing. C-130s, it is not a given, and that is the approach that we took with our group and our research, is that many of our traditional assets that we're relying upon to be there, they could get shut down or disabled in some manner. And that kind of talks about our real capability. When you look a little bit deeper into our aging fleet when it comes to airlift, and it's not exclusive to airlift, our aircraft carriers are in the same boat, our transports, our Navy, all of our traditional gray tail assets are kind of in the same boat where maintenance costs are going up, logistics costs are going up, and they're aging. And if you are against an adversary that has a long-term game, you just wait until we have so many exercises until we fly the wings off of all our planes and then you attack, right? That's just me. That's how I would think of it. To highlight some of these concerns on kind of a more specific scale, we've highlighted a particular market in the DoD logistics enterprise, and that is what's called MICAT. which is mission impaired capability awaiting parts. So what this means is that there's a C-17, a C-130, aircraft carrier, it doesn't matter. It is downrange and it is broke. It cannot complete the mission that it was built to do. And it is sitting there waiting until we get an O-ring, waiting to get a special wrench, a piece of test equipment, something to get it back in the air, back in the fight. That is what we're talking about. We're highlighting that very specific market. In order to kind of research and kind of go about this, we contacted Tesseract. Tesseract is another innovation group up at Headquarters Air Force, and they have been also given how do you solve logistics. So in a effort to do this, we talked to an analyst, and he said that he kind of launched this project called MyCap Prime, right? MyCap Prime, he attempted to get after this problem that I just kind of highlighted and mapped out for you. How can we get those parts somewhere faster, right? And what's kind of funny is all they did to improve the process is pay attention to it. So a lot of times it's the very little things, right? It's the logistics airman that goes and gets his hair cut instead of taking the part off the shelf and in the box first, right? It's that kind of stuff. That kind of stuff is eating our lunch just a little bit, but all you have to do is pay attention to it, make it a priority, and suddenly you're about 20% better in some cases, right? So that's kind of the thing they were looking at, but they had no innovative idea. They didn't change the process at all. They just paid attention to it. And when scaled up, they found they weren't all that successful with just paying attention to it. So what we've asked is, how often do you have a MyCap that's small, mass-wise, right? Under 1,200 pounds, let's say. His answer was between 95 and 98% of the time when a DoD asset requires a part, requires a piece of test equipment, this MyCap space, it is under 1,200 pounds. So not very big, not very heavy. Every so often, yes, it is an engine, right? Every so often, yes, it is something big. Our solution is not going after that. You can't get around moving an engine. You need something big to do that. But we're focusing on that 95 to 98%, those small things. For instance, an O-ring, right? So there could be a plane downrange waiting for an O-ring, something that's about that big. Anywho, volume, right? So our solution is not so much after volume. When asked if these MyCap parts could fit in basically a wall locker size, about 50 to 60% of all MyCaps are about that volume size that could fit into a travel pod. If you're familiar with a travel pod, they can be equipped onto fighter aircraft, and they have limited volume. You can put some things in there, but not something large. But about 50 to 60 of our MyCap markets can fit into something as a travel pod. So that's kind of where we're going. Also, what Tesseract had to say is that about 97% of our logistics is done in coordination with commercial assets. Why is that? Because we have a lot of smart people around. When we generate a supply pool anywhere in the world, it doesn't make sense to put these one or two items on a C-17 and fly it, right? You have to fill up the plane in order to justify the cost requirements of flying that plane across the pond or wherever. So what ends up happening is they turn over to commercial and they say, hey, commercial, I'm going to put this part on a truck. This truck's going to go to wherever, and you're going to put it on an Evergreen 747 or some other asset, and it's going to fly somewhere. You're going to put it on a truck and then to the base, right? So all this kind of rig and roll stuff. And kind of going into a little bit of my lean practicing side of the house, what we kind of determined is there's a lot of batching. And what batching means is that you are waiting until something is full before you send it. And the problem with batching is a lot of time that waiting, other people are waiting too. So let's watch this quick video to kind of illustrate what this is. right? So at the top, think C-17, think a big ship that needs to be full in order for you to justify moving it across the pond. Down below, in the middle, you have something a little smaller. And down at the bottom, you have something where you can load it, it's full, you send it, it gets to its spot, you repair, you resupply, and then you apply your effect, whatever that is, right? Ranging anything from fixing the plane, dropping the cargo, and killing people, right? Anywhere within that range, you're applying effect, but you're waiting on something. But if you are batching, it will take longer, almost every time. Now, if you have a small batch size or a single piece flow, when you can match the customer demand with what you can deliver quickly, you get it there faster and you can apply that effect faster. All right, so before we're going to talk about 2 wrong solutions. We're going to talk about what we're currently doing, and I even have a bonus wrong thing, if that makes sense. I missed the slide. So here is the kind of the defense. So we're talking about contested environment. If you see all these lines, you see there's a bunch of bad looking things over there. All right. So it's a crowded slide, but that's the deal. You can see there's a lot of allies that are within that first ring. You can see there's a lot of defense components that you should be concerned about. Absolutely. First wrong solution is, can we continue to do commercial, right? This is what would happen if you did commercial. Your famous evergreen 747, I've seen it all over the world. 747 is a beautiful aircraft, very good. We passed it up for the C5. But anywho, it's going to go up and it will get about right there, and it's going to turn around and it's going to say, I ain't going to get shot down. That's not my problem. Now, you may say, okay, what if we nationalize? Yeah, sure. If we nationalize, that could be a thing. It still doesn't have defenses. So it still wouldn't be worth sending into that second ring, because very likely it could get shot down very easily, right? So 0 successful deliveries, 0 effects, lives lost. Now, it didn't get shot down. However, there is someone waiting on that part. There is someone waiting on that delivery and they didn't get it. Go ahead and connect the dots on that one. Wrong idea number 2, Gray Tails, right? Our mighty airlift squadron. I've been at Travis Air Force Base. I remember taking my dad to the airfield, and he looked at the airfield and he's like, man, there are several nations that couldn't combine their air forces to create what's in my field division right now. Absolutely true. So let's see how they do. All right, so I'll give you 3 C-17s. And here they come from the CONUS. We're trying to connect the industry with our forces, right? They get past the air defense. That's where commercial would turn around. They get a little bit further, but let's start thinking about attrition, right? We were able to get to Japan. We were able to get to the Philippines. Maybe one will get through to somewhere where we'll need to resupply. Maybe one will get to Taiwan. But here's where it starts turning upside down, right? So we're going to continue to take attrition, and that C-17 is going to be stuck in Taiwan because it needs a part. We're going to send another C-17 to go get it, and that C-17 will get shot down. And then China will get a long time to do this. They'll just take it out, right? So that is contested logistics, right? And when you use exquisite assets, they're very hard to replace. They're very expensive. Lives are lost when they're shot down. Are you going to win a war of attrition in their backyard? Bonus wrong. So I've seen this on a couple different things. So there's this space asset, and there's some other entities out there. So for instance, the Australian guy turned me on to something that DARPA was doing, which was like this fuel train, which was really cool. There's another entity out there, the Marines. So I'm speaking to 2 Marines. They're doing some great stuff. They are using smaller drones in mass, in swarm, to deliver within short ranges, right? So although that's effective. That is good for that problem set. they're making great progress there. That's no doubt. And that's similar to what Amazon, Google, some of these other companies are doing. But our problem set is a little bit different. We need to go a long ways. Those other quadcopters, so if you see non-fixed wings drones, those are more short range. They can do what we're trying to do maybe 20 miles out. We are trying to go like 3,000 miles. All right, we're trying to go a long way. But talk about the space thing. So what does that look like to you? A, this is mostly conceptual. This is not going to be ready in 5 years. This is not, this is way out there. A, it's expensive. And B, it still doesn't solve the batching. You still have to batch this. You have to fill the rocket in order to send it. Right? So that doesn't solve that. Plus, that looks like an ICBM. So if I was China and I was a master at our adversaries, and I was a master at information and deception, I could change the narrative on that really quick, and then I could start nuking you because you just provoked me, right? So that is what I'm concerned about. Granted, yes, by all means, keep going after the space thing. Maybe it will work in the long term. There's definitely some promise there. But let's get to what we're talking about. So currently in the Air Force research laboratories, there is an item that has been cited several times, and it is the XQ-58 Valkyrie from Kratos Security and Security Solutions, right? What is it being developed for? So a couple RAND studies came out, and it's very good at ISR. It's very good at dropping bombs, and that is what it's being developed for. It's combat and ISR. What we are saying, and we'll get to its performance characteristics, is we need to take this same thing and start putting logistics requirements on it. It's attributable. That's another big part of the solution, and I had never heard of this before. But an attributable asset is something that is so cheap and can be made so quickly that it's okay if you shoot it down. You can have about 300 of these, and I've talked to the engineer. He could say he could have 500 by 2025 in the air, operational, good to go. And some of them are ISR and some of them are combat. Say you shoot down 30 of them. Well, 260 of them, or 250 of them still made it, right? And you can replace those in a couple months. That's what makes this attributable asset very, very attractive. It's cheap. You can make a lot of them. You don't mind if they get shot down. They're runway independent, which is awesome. They're developing a couple different models to where it can land on an aircraft carrier. It can also land in the water. And they have a way to adapt it to runway, traditional runway landing as well. So those are all things that are under development. It's also autonomous. So we have to think about that too. No pilot. Also no remote pilot. It's mostly AI software driven stuff. All right, so let's talk about the range, and this is kind of what makes this special. Max range, over 300 nautical miles one way. So I have that one spot in Guam there. You could go almost 2/3 of the way through mainland China. So if it's a one-way ticket, if you have other runways or bases further along in this area, you can land them, they can refuel, they can go back. Yes, they take traditional fuel. The engine that it has is a normal small business class Pratt & Whitney engine. It is made to be produced quickly, fast, and cheap. And it takes the same fuel. So there's nothing special there. All of our infrastructure in this area can refuel any one of these things. The other big spot to pay attention to is the payload. So remember I said 1,200 pounds earlier with Tesseract. It can hold 1,200 pounds and transport it that way easy, no problem. It's also fast. Round trip. So this is what round trip would look like. And you can put that dot anywhere where we can refuel it. You can put it in Taiwan, you can put it in Philippines, Singapore. It's right there in Okinawa at this moment, Japan, South Korea, any one of those things. Next, we are going to kind of further this technology. I saw in one of the other panels, one of Professor Nicholas Nelson from Georgia Tech University said something really, really cool. We have a tendency of focusing on all these different technology advances singularly, right? AI, right? Let's focus in on AI and think about that. Autonomous drones, right? That's another hot topic. Let's talk about that. Let's talk about space delivery. Let's talk about additive manufacturing and 3D printing. Yes, we considered it, right? All of these things are developing at the same time. So what puts them all together once they're mature, right? Additive manufacturing, yes, the Marines have some of the best stories about additive manufacturing ever. They are just killing it with printing things downrange. But those 3D printers, although they're advancing further and further, they still need the raw material. You still need to develop the matter to where it gets printed, right? You can't get around that until we have a teleporter from Star Trek. We don't have that yet, right? So I want you to consider this, and I'm going to play just about a minute of this clip. And this is from Dash. This is another company. This is another logistics innovation that is ready. Imagine the XQ-58 Kratos, or from Kratos, the Valkyrie, having this equipped.
You want to be quick. The second you land the plane, you're not efficient anymore. So land the package.
You now have an opportunity to fly over 2, 3, 4, 5 delivery locations.
There's just a few main components of what we do. We make the software that automates the airdrop mission. It's easy for them to implement. We also make the cargo handling systems that get things out the doors of aircraft. And then finally, we make these precision airdrop vehicles that allow things to get safely and precisely to the ground. When you put that all together, you get a system that allows really low friction delivery from any aircraft to essentially any place on the globe.
Once the pod is in the air, the pod itself is performing guidance and real-time control.
We are creating a fundamentally new channel, and that channel is in the sky.
The customers you talk to, they've been told no over and over again. We can't deliver to rural locations. We can't deliver the day after a hurricane. As long as you can fly over that location, you should be able to deliver to it.
To even the most remote part of Africa, Alaska, Canada, you name it.
Being an innovator takes a lot of courage.
Yeah, I know the music gets me anyway. I keep wanting to watch that video over and over again. But can you imagine that? Can you imagine a stealth drone, 500 of these, flying 300 nautical miles away, dropping these anywhere we want? So we talk about agile combat employment, right? These bases that are invisible and keep moving around. This lets you do that, right? It can drop anything you want, that as long as the volumetrically, it can't drop an engine or a tank, right? But also it creates the cover and the environment to where, yes, some of these are getting shot down, but every so once in a while you get a C-17 in. Every once in a while you get an escorted fleet of 130s. You use your exquisite assets way, way better because this allows the logistics platform to move forward in that manner, right? So round trip, you can be dropping these anywhere back and forth. Let's get back to the batching. So this is what it would look like. And I'll play this a little bit briefly because we watched the whole thing earlier. And there we go. So you got the C-17 on top, 130 in the middle, Kratos on the bottom. You know which one's faster. You know which one gets the effect applied faster. This solves the batching. Next, how does this look like in our scenario? Right, see all those little things? They can penetrate deep. They can go anywhere where our allies are. You don't mind if they get shot down. And notice the scoreboard. I had, what, 3 C-17s earlier? And I'll get to money because I know Doug wants to hear about the money. This is the equivalent of 3 C-17s worth. You can have 1,680 deliveries. If you got shot, one of them got shot down, okay, take it down. But the effect is needed, is applied. All right, next thing. So and this is highlighted in a RAND study. And this is a little panel engagement. Go ahead and pick the one that's combat. There's a few of them. All right, but if you are a SAM site, something that can shoot down airplanes, that's your job, you have to pick the combat one out of something like this. Some of these are just carrying a wrench. Some of these are just carrying a bottle of water. But you have to pick the one that is combat. All right. These little C's, those were the combat ones. If you didn't pick that one, you're dead. They just dropped a bomb on you. The ISR ones, they were jamming you the entire time. All right, to Doug's favorite part, show me the money, right? And this is where we get to compare those attributable assets, right? This is very confusing, like very crowded. I put some work into this. What's cool is this RAND study right here. What they do is they work with Kratos and they compare the XQ-58 to F-16s, F-15s, F-22s, F-35s, and remember, it's being developed for combat. So they take an applicable mission and they compare them to the next cheapest asset and see how they compare. Long story short, people, equipment, fuel, acquisition costs, maintenance costs, all of those things are in that study. 1/5 of the next cheapest platform, which is an F-16. 1/5 to complete the same mission. What I did is I went to the public data on sustainment for the C-17 and I plugged that in and I said, instead of dropping bombs, we're dropping cargo. How does that stack up? And this is where I have to go to my Excel to show you how that looks. Yeah, let's stop that real quick and go here. Are you guys able to see the Excel? Thumbs up. All right. So I had someone that's good at, return on investment stuff and put this together for me. So this is over the cost. So currently the requirements that are levied upon the Kratos project say, can this thing fly 20 10-hour missions, right? So of course, the only thing they advertise is, yes, it can. So I went back and I asked, how long can these things really last, right? The answer is 20 to 30 years, as long as they don't get shot down or broke. So I took that premise and I said, no C-17s get shot down, no XQ-58 cargo type missions get shot down, and payload to payload, how does it work out over a 20-year span? So initially, the C-17 is more efficient when it comes to cargo load, but it's not more efficient with O&M and maintenance costs. Right around year 5, you start to break even, and the Kratos, this small little drone, can actually deliver things more cost efficiently than the C-17 after about 5 years, right? And what are the total savings if you add it all up? It's about $3 billion, right? To have that gray tail capability versus the Kratos capability. All right, let's finish up the PowerPoint. We're almost there. So what is the point? Where do we go from here? What is the conclusion and the call to action And this is kind of where we're stuck. I know Doug talked about this. I know John talked about this in our pre-thought. Is there's a lot of rub here, right? Like, how do you get this to happen? And right, so national defense thought leaders, right, such as like the author of The Kill Chain and all these other books, right? They're calling for major changes. They're calling for these paradigm shifts, and it's almost like we all know it. But what is stopping us, right? There's some big considerations here, right? So we have a lot of our leaders, in particular with the Air Force, are pilots. There is a pilot-centered culture, right? There is a little bit of a bias there. There's a lot of anxiety when it comes to replacing pilots. So that might turn this off. The other thing, and probably the most important thing, is this will disrupt the supply chain a lot, right? There are a lot of people making a lot of money off of repairing C-17s, repairing KC-10s, repairing C-5s. When you go to an asset like this, it comes with the supply chain. When you have 500 of them, you just can the parts from one to the other as needed. So you don't have all these people making tons of money. And I have a feeling, and the Kratos shares my sentiment, that this will essentially kind of piss off some congressmen that have a lot of constituents making these parts, right? It will please greatly the one that makes the Kratos, for sure. Right, but we don't need to fight Congress right now. We don't need to fight this crazy war. So what we do need is we need to start taking logistics seriously. We need to add these logistic requirements to these currently developing platforms, right? Boeing has a few, there's a couple of them out there, but they're all ISR, they're all combat. They like to put that little asterisk and various other missions, but logistics is important. Like, it's gotta be put up there with combat and ISR, it has to. Or else we're gonna get punched in the face and we're not gonna know what to do. Next is we need to start getting these into the hands of the lower decision makers, right? I've been a party of a pro suit before on the flight line. Would I know how to use this even if I had it? Right? I don't think so. I don't know, and I can't answer that. Like, there's a couple RAND studies. Yes, there's a bunch of smart people, but until we get these into the hands of the people, the decision makers and the users, we're not gonna know those little things. And do we really even know if this works, right? Start putting these into some higher level simulations, some exercises, and think about what contested logistics looks like when you have a platform like this. And finally, Napoleon Bonaparte, this is a good one. Amateurs discuss tactics, professionals discuss logistics. And if that doesn't do it for you, you can go back to Mike Tyson and watch him hit a speed bag. It's fast, it's small, it's quick, it keeps our forces moving, it keeps our exquisite assets from getting shot down, and we kind of have that advantage of that eventual haymaker that is about to come. That's all I got. I'll turn it over to you. It took up a lot of time.
Hey, Doug here real quick. Connor, great presentation. I do know there's one quick question in the queue. I want to give you a chance to briefly hit that and then see if myself and John can offer some questions or thoughts moving forward. But the question is really on are countermeasures necessary for delivery drones, without ISR drone support?
Right. I would say that's one of those decisions that we need to test. Right. I would think in the decision matrix, right, whoever the customer is, like if they're, let's say, deep in China mainland, right, and there's a lot of, we know that there is a lot of defenses, then yes, maybe, right? But if it's between two areas that we know is relatively safe, and you want to move like 500 of them to get that desired effect, then no, I would say not. And if it's EM spectrum issues that you're talking about, this drone was designed for that. It's not a problem. I'll just leave it at that.
Hey, Doug, I think one of the things you mentioned before, and this becomes, in the world of procurement and development, this will absolutely lead to a cost. the UAV game, we get very focused on tech, and as silly as it sounds, often physics gets forgotten, and physics matter. And so when you start building technology that is really big, that's going to go really far, that's going to land in a little given geographical space, that's going to carry countermeasures, that's going to carry frequency selective services, your cost, size, and weight goes up, and then physics gets in the way. So that's a tough question to ask in a general context, but the simple answer is it's going to be mission specific and our TTPs. So the thing, like an adversary like China fights us in numbers, in scale. So when you see this concept of throwing a lot of drones, what we really have been trying to do strategically is, can I make a cost of a drone exceptionally low and make them fire a very expensive missile, which they have a lot of. So this one technique against that adversary is defeating their ability to scale en masse. So I know that doesn't exactly answer your question, but it really would depend on the mission and the TTP we're trying to employ.
Hey, while we're waiting on further questions, one thought I have is, who would be the advocates? Who would you envision as major stakeholders who would want to stake this as a future way forward? It's not just the Air Force. Who else would you say as stakeholders?
Yeah, that's a really good question, and we have a few that we have in mind, but I'm definitely open to suggestions on this one. So there's an Air Force effort out in Indo-PACOM called FLOSS, where they're trying to make this mobile floating repair ship, but they have no means of transporting their finished goods to and from. So this would definitely be that. But right, this is kind of a paradigm changing, right? So SOCOM would be very interested, and that's who's employing them right now. Footing the bill, I guess you could say. This one, we're thinking about going with AFWERX, right? With their phase 1, 2, and 3 program, if you're familiar with that one, where essentially, if your concept is good enough, they put the ball into Kratos's court, and they say, go DoD wide, and you do the research of who would want this, right? There's just too many, CONUS, contested or not, that need delivery services like this. For example, the first person that came up with this concept was actually De Beers. De Beers called Kratos and said, hey, can this thing transport diamonds across the ocean? Right? That was the first time that the engineer was just like, whoa, this isn't just for combat. This could be for small, fast deliveries. I think there's a lot of people that would want to do that. It's just the effort of finding them is hard, and getting them to put their money where their mouth is even harder.
Hey, Doug, I'd like to take your question and throw it back at you. From your perspective, I know that the Marine Corps, as you know, being an artillery officer, you guys are log heavy, you're not as light. And at the tactical operational level, new below, there is a tremendous amount of level of effort planned on, focused on logistics. It is always an enormous planning consideration. But we're talking about a problem that is this tyranny of distance. And it is really a resource problem and cost. And I know years ago when the Marine Corps, not that long ago, looked at, they really wanted to focus on putting in the POM a specific UAV that was log designed, because they knew culturally, operationally, if it was a multi-purpose UAV, it would dynamically always go to ISR and strike. So it would be interesting to see your perspective on, from an advocacy standpoint, more besides the operational component advocacy, whether it's congressional or otherwise, of how to kind of flip that way of thinking.
Sure, I'll take a quick comment on it. Before, and I mentioned to Connor that it's all about the Benjamins. It's all about monies. Title 10 determines the vast majority of our budget. So train, man, and equip, that's the services. But with that, you also have advocacies at the Office of Legislative Affairs on Capitol Hill. And, they're plugged in to find out when something is made, how many congressional districts benefit from it. But you also have combatant commanders who have an input mechanism. They have this process called the IPL, the Integrated Prioritized List, where they took a look at their war plans and try to prioritize, hey, the services aren't giving us these things to do things. So perhaps in this case, Indo-PACOM could be one of your major advocates. Perhaps Transcom could also be an advocate. Special Operations Command has different funding capabilities. Interagency. I mean, you could consider, the CIA and other organizations that, might have a discrete mission. So I would say there's a large possibility. It's just a matter of selling that idea to the people with the checkbook, because ideas are great, but if you don't have a sponsor, then they die a quick death. I think we've got a couple more questions in the queue. Connor, I don't know if you can see them. If you want to take a look at those and take a pick at one.
Yeah, let's go with Kim. That's the first one. Would the Air Force want to go with a Kratos solution? Would a competitive solution be required? Are there other drone solutions like Kratos aircraft? So yes, this would go to that. I use Kratos because it was the best kind of avatar for these type of things. Now, right, I've been in contact with the engineer quite frequently. He says that, of course, his product is the best and, it has no equal. But there are other things that could do the same thing, right? Boeing has a good one. General Atomics has a good one. So yes. And what's special about Kratos and kind of the business market that they occupy is they're able to go from concept to production very, very fast, right? Because they're dealing with small things that are malleable. I think the Valkyrie is actually a phenomenal example. They went from concept to production model in about 2 years, which is basically unheard of for everything else. I mean, the KC-46, how long have we heard about that one? And it still can't do what we asked it to do. It's just nuts. High threat cases is from John. A Valkyrie plus jammer would escort Valkyries carrying logistics? Absolutely, 100%. Yep. So that is one of the main missions that they're developing the Valkyrie for. They're just not considering logistics at all. What are the potentials for drone? That's from Nick. To drone countermeasures, right? So this is a big, big deal. Yeah. Yes. I think the question is, do you let them have it only? And you just kind of quit? And then they have it and then we don't? Because they don't hesitate. They don't stop. They don't have any thing that says, like, don't develop this. They're going to develop it. So I think the thought is there, right? So say we roll out with this and then they roll out it with more. Yeah. I don't have the answer to that. That's a tough one. I think in my head, I'd rather have it too. UPS, Federal Express, Amazon, do you think there are commercial applications? So yes and no. I would say for this solution, CONUS, right, applications, yeah, you could use it for MyCap, like today. From McGuire to Travis, you could fly all day long carrying those little bits and pieces and you would end up saving tons and tons of money. So the contingency response wing, right? They would love this thing to be able to drop those packages right after a hurricane in Puerto Rico, anywhere. They would love this thing. Now, UPS, Federal Express, Amazon, they are working on their own thing. So is Google. But it's more of those short range things. They are assuming that they are going to have a hub nearby within 10 to 20 miles of their customer. I'm sure they'll brush that out once they develop it. John?
Yeah, Doug, so to your point, if you go to the FAA, those large carriers, and it's driven by regulatory, the concept that Jeff Bezos 60 Minutes thing years ago, where they're flying at 400 feet and they're delivering it to their house, there's enormous regulatory hurdles that they're still struggling with. Where the FAA thinks, I should say, or where the carriers are most likely going to show up first is the large commercial carrier, 737, whatever they're utilizing, because the technology is highly mature. They're flying at altitudes where there is much less dense traffic congestion with aircraft versus 400, 800,000 feet with small commercial Piper Cubs, and basically integrating autonomy. They're gonna basically approach it like they did with cars. They're gonna have a pilot sitting in a seat, which is like a safety pilot. So I think what you're gonna see in the commercial world is that application becoming real before you see quads delivering packages to your home. At least that's what the technology is showing at the moment.
Yeah, I think that reminds me, talking to one of the Dash people, they said there's a little bit of a wrinkle in the regulation where they assume that the plane lands to deliver. So there's like a small little loophole, and that's where that Dash company kind of comes in. Don't land the plane, just drop it. And with the 737, you can drop a whole bunch and it can just guide it down. That would be pretty cool.
Yeah, and there's just enormous regulatory problems from dropping things of a certain weight. I'm talking over 5 pounds, whether it's guided or not. So someday that technology is going to be there, and people like the FAA are going to be comfortable with it. It's not going to happen in a year. It's going to happen in 2 years. So this is just about maturity of the technology and growing comfortable with that from just a pure safety perspective.
Hey Connor, it looks like we are running out of our time limit, but is there anything you'd like to close with? And I personally just want to say thanks. I think you've got some good ideas. I'd like to give John a couple comments first and then give you the last comments. But think about advocacy, think about funding. I think that you're on the right track with that. The other thing is going to be readiness reports and training. You're going to have to figure out how to integrate that. So think about it from a doctrine standpoint. I think you've got a good start to some innovation. So congrats and good luck to you. Turn it over to John, and then I'll let you have closing comments.
Thanks, Doug. And the advocacy piece, as Doug stated, I think is tough. I hate to say, I have no idea how to create that, because if you look historically, we talked about, it's been a real challenge. But technology there's a lot of paces in technology. And so when you think about this, one thing we haven't talked about is denied GPS. And there are many methodologies that have been repeated over the last 25 years. All those aircraft that get to target have to use an alternative to GPS. And I'm confident in saying that is not solved. They will show you in a constrained environment how they will get there. So that, I would say, has to be a part of, if projecting the solution, that has to be addressed in the thesis. But I mean, very interesting. Congratulations on everything you've done. And you're addressing something that is extremely a high priority, the security of this nation, and best of luck.
Oh, no, thank you. Thank you, Doug and John, for both your inputs. I think I'm going to hit you guys up afterwards, because Doug mentioned a few different avenues that I haven't heard before. This IPL, definitely got to hit that up. And right, yeah, navigation is a real deal. I've talked with the engineer about that, right? So INS, they have a pretty robust INS system on it, inertial navigation, which gets you so far. It is independent, but right, from your expertise, maybe not good enough. So that's one of those areas we have to see it in live, in person, to really get it. But no, thank you so much. I'm happy that I haven't been told no yet. You're stupid. So that means keep going forward. We came up with this idea somewhat early, and we're still waiting for someone to say you're wasting your time, that's stupid, and that hasn't happened yet. Thank you, MGM Works and Margaret, right? I've asked Margaret for a whole bunch of favors on this one, and she said, great, you're going to have to do this one for me. And I'm so happy I did. It's definitely uncomfortable, but thank you for letting me show the work.